Hey guys, Mr. B here again, bringing you another math video. This one just a little short introductory video on the chain rule, with maybe a couple of examples, see how it goes. So the chain rule is a rule that we apply to composite functions. So what I mean by composite function, here's an example, is something like this, where you have y is equal to, I don't know, 2x plus 5, and then to the exponent 5. So this function itself is composed of two different functions. So you can see inside the exponent, you have a linear function, 2x plus 5. So that's, your inside function. So you may have heard this in the form of f of g of x or g of f of x or something like that. So this guy right here is the inside function. Now the outside function is this exponent 5, so x to the 5. So there you have two separate functions. So when you have a situation like this, the best derivative rule to use is the chain rule. So, the best way to sort of see this guy in action is to actually do an example. So let's do one. Actually, let's use this example here. So let's see what I got here now. So let's find a derivative of y is equal to 2x plus 5 all to the exponent. I'll change the 5 just because we already got a 5 there. I'll change it to a 4. Whoa. Well, my computer is being a pain in the butt here. Hang on. Boop boop boop. Let me erase that for 1 second. Alright, so let's try this again. I'm not going to remake this video just for that little mistake, guys. Come on, be serious. 2x plus 5 all to the 4. Why can't I do an exponent of 4? Here we go. Alright, so first thing that I like to do, now let me just write the chain rule up over here. Y prime is equal to f prime of u dot u. So in terms of your f of g of x, if you're thinking about in that context, I think of it in the f and u context. Don't say that too close together. Especially to your teacher. So where fu is the outside function and u is the inside function. So what we have here, and usually, like I said, it's up to you what you do. If you write this stuff out, you do it in your head, my suggestion would be, if you can't do it in your head, you haven't done enough examples. But for my students, when I'm doing these examples in calculus class, I write them out on the board, and I write step by step. So identify what my u is, and my u is 2x plus 5. So my u is the inside function, in terms of the f of g of x context, g of x. And then the outside function, or the entire thing, is fu, and that's u to the 4. So now, I'm just going to pause this for a second. My phone is going off there, guys, so back to you. Alright, I'm back. That was short. Okay, so now what I need to do, so I got my u, 2x plus 5. I got my fu, u to the 4. Now I need to find the derivative of these. I forgot a prime in my rule up here. So now I need to find the derivative of these guys. U prime and f prime of u. So the derivative of u, or derivative of 2x plus 5, of course, that's a linear function, so I'm left with just 2. And then u to the 4. So this derivative is with respect to u. So what I mean by that is you don't need to know anything. Just think of u as x. This is what I tell my students. So it becomes 4u to the 3. So I just use the power rule. So the exponent times the 4 times the coefficient of 1, so 4. And then subtract 1 off. So there we go. So I use the power rule, and then power rule for both, basically. So now I write out my chain rule. So y prime f prime of u times u prime. So f prime of u is 4u cubed. U prime is 2. So I can multiply these two guys together, so I get 8. And then I'm going to replace u with what I decided u was, which is 2x plus 5. So 2x plus 5 all to the 3. So that's my derivative right there. So it's nice. Beauty. Alright, so that's one example. of using the chain rule. Let's do another one maybe that involves a radical. So let's make this one up. So let me see, y is equal to the square root of, let's keep it simple, x plus 3. Alright, so here's a straightforward radical example. You might have probably done one of these examples using, say, the definition of derivative before. So with the chain rule, it's a much more straightforward question, type of thing. So in this case, my two functions are the root function and what's inside the root function, so the x plus 3. Anytime you have something inside a radical, you got to be thinking chain rule. Immediately think chain rule. Alright, so let's declare what my u is. My u, not u prime, u is x plus 3. And my fu, didn't mean to say that so meanly, is root x. So I did a video on finding the derivative of root x, so if you're not familiar with it, go back, search it out on my YouTube channel, and then have a look at it. So I'll give a little brief explanation here, of course, too. But you know, if you really want an in-depth look at it, if you want a closer look, then you can go there. All right, so I got u prime. So I'm just going to use the power rule again. So derivative of a linear function is always just a constant, whatever's in front of the x. So I'm left with 1. And then for the derivative of fu is f prime of u, and that's the derivative of this guy. So it may help you to think of root x as x to the 1/2. So I'm going to use the power rule, take my 1/2, goes in front, so 1/2 x, then I'm just going to subtract off 1 from 1/2, so I end up with a negative, not I wrote x, there should be u, so right, I hear you guys screaming at the video already. And then I go 1/2 subtract 1, so 1 over 2. Alright, so now I just use my chain rule, so y prime, always a good idea, guys, in calculus, to write out the derivative rule that you're using. At least if you mess something up, the prof says, well, man, you used the right one, you got it right there, so you never know. Alright, so you got this guy, 1/2 u to the negative 1 over 2. And then u prime is just 1, so I don't even need to write that in. I'm just going to put in what u is. U is x plus 3, 1/2 x plus 3 to the negative 1 over 2. Now, if you want to get rid of that negative exponent, so remember that all you need to do is take it to the bottom. So it becomes 1 over, and then I got the 2 part. And then remember, so if it comes to the bottom, it becomes x plus 3 all to the positive 1/2. And then I make that exponent, since it's just one exponent of 1/2, it becomes root x plus 3. So there it is, guys. 2 examples of using the chain rule. One of the most useful derivatives. And once you know it, you can guarantee your prof is going to throw a question at you where you have to use the product rule or quotient rule, and within that you have to use the chain rule. Chain rule is especially useful for trig functions as well. So I got a few other videos on trig functions. Go search them out. But yeah, this is definitely an important derivative rule that you need to know. Alright guys, take it easy.